everyone, I'm Sumayyah Alamoudi, and today I'm excited to share with you our research on exploring semantic question generation, methodology, and a case study for algorithmic question pool. This research is a collaborative effort by me, Sumayyah Alamoudi, and Dr. Amany Alnahdi from the Department of Computer Science at King Abdulaziz University. In the realm of education, assessing student performance is pivotal. However, the traditional process of formulating questions and creating tests demands considerable time and effort from the instructors. Our research aims to improve this process by introducing a semantic methodology for automating question generation in the field of algorithms. And here is our agenda. We will go through introduction, then problem statement, related work, methodology, case study, and then finally the conclusion and references. First of all, we will introduce what ontology is. The ontology is based on description logics, and they are commonly called logical ontology. The ontology is a graph-based knowledge representation that shows properties of concepts and the relationships between them. The ontologies can be utilized and used in education because they allow formulating the representation of a learning domain by specifying all concepts involved in that domain and the relationship between those concepts and all properties and constraints that exist in a specific domain. Here is an example of the algorithm ontology that we are going to generate questions from. As we can see that the concepts are represented in ovals and the arrows are representing the relationships between those concepts. For example, here we have is a relationship between sorting algorithm and algorithm. So a sorting algorithm is an algorithm. And here is another property of this concept, the selection sort, that has order of n squared. So the ontologies have aided the development of tools for generating knowledge assessment. And these tools can be used in interactive learning systems to give a cost-effective solution for generating questions automatically. So what is the problem? The problem is that assessing students require much time and effort from the instructor. And the current learning management systems, such as Blackboard, Blueprint, Question Mark, and others, are limited to assisting instructors in storing the questions and grading. So the current LMS have limitation in automating question generation. Now we will go through related work. We'll go through logic and ontology, ontologies in education. The ontologies in education, we have the automatic question generation methods and the generating questions from ontologies. So the ontology is a concept that is used in multiple domains, such as in philosophy. In philosophy, ontology is a discipline of philosophy that studies the meaning of existence. While in mathematics, it is a directed graph whose nodes identify certain concepts, class of objects. For example, if we have here this concept N1 and another concept in N2, and there is a directed edge between N1 and N2, we can say that N2 is N1. In computer science, ontologies employ this philosophical concept of knowledge representation of the reality of domain or knowledge as a reference point. Ontologies in education. In the IEEE database, ontologies have been used to describe learning domains by 41 systems during the previous years. For example, we have ontology for chemistry called ChemOnto, and another ontology in natural science. While there are few ontologies in the computer science field, but the authors here built a computer-related ontology from the NSC document database, and another ontology for Pascal programming languages. Programming language ontology is created, and SQL ontology also created. So the automatic question generation approaches can be categorized into three categories: the natural language processing, the template-based, and semantic-based. For the natural language processing, the technique natural language processing techniques generate questions using automated text analysis, where in template-based method, they use a predefined patterns or templates for inquiries. And finally, the semantic-based approach automates the examination creation by utilizing semantic web technologies. We found out that semantic-based techniques have several benefits over the other two categories. So now we'll go through the researchers that generate questions from the ontology and how they use the ontology to generate questions and the methods they use. For example, in biology domain, they build an automated question generation based on biology ontology to evaluate students' understanding of the biological concept and the relationship between them. They developed a new strategy for generating multiple choice distractors. In natural science domain, they developed an automatic question generation based on the natural science technology. This ontology is created manually by experts, and the goal of this system was to evaluate students in grade 4 and 5 in natural science subject. While in computer science domain, they proposed a framework for the assessment process, which includes automatic question generation, answer extraction from corpus, and automatic grading. They built the ontology based on multiple documents from the NSC document database that contains 520 documents in computer science related fields. Another ontology, Pascal ontology, it conceptualized the Pascal exercise solution to help learners better comprehend and query programs. And they proposed a framework for creating SQL assessment automatically. These questions are generated from the information stored in SQL ontology. On the other hand, in natural science, they used chemo-ontology to generate questions for practical chemistry labs to help students with self-assessment. But the research gap was that there is limited work in using technologies in the domain of computing involving algorithms domain. So our proposed methodology was for generating questions, and it consists of 5 stages: the ontology determination, ontology analysis, generic stem creation, questions generation, and validation. In the state of ontology determination, we identify the ontology of interest. And then in the ontology analysis, we study and analyze the ontology to identify properties for question stems. In the generic stem creation, we generate generic question stems based on the ontology analysis, focusing on key properties. In the question generation, we generate questions based on those stems and ontology axioms. In the validation, in the final state, we validate the generated questions. So in our study, we are interested in algorithm domain. So we use algorithms ontology. This ontology is created by experts in computer science. The experts are professors in computer science domain. This ontology contains the basic and the fundamental concepts and the important concept that is important for the students. So the algorithm ontology has 403 axioms and 114 classes, 6 properties, and 23 instances. In the step 2, we do the ontology analysis, and here we have the analysis of the properties of the algorithm ontology. Here it's presented in Protege editor. We have the properties belongs to algorithmic paradigm, has a running time, is equal to, is greater than, is less than. We used is equal to, is greater than, is less than for computational and analysis questions, specifically for computing the complexity of an algorithm. And as we can see here, the properties are by the ontology is because the ontology is bilingual. Here we can see the Arabic and English. So after that, the generic stem creation. For the generic stem creation, we create stems for each category of the questions. Here's a general question format is then the subclass, and we have the relationship a superclass. So here we are taking the is a relationship concepts. And here we have this algorithm has algorithm running time. This is using the algorithm running time property. And here we have what is questions. We have many question categories, such as definition, concept completion, quantification. For example, here for definition, the question can be defined, then the axiom or the concept, and we can say what is meant by the axiom. And the concept completion, we can say explain what is the axiom is and explain the term, and we put the axioms here. For the quantification, we have list 3 general, for example, of the concept. Can you provide an example? Give an instance where that can be applied. Here's more categories for feature specification and concept completion also. We can ask questions like enumerate the features of this concept, list the characteristic of the concept, provide 2 advantages or 3 of this concept. And for concept completion, we have with regards to, here we put the superclass or the class, and explain the differences between the subclass and the other subclass. Then the question generation. We can see here that the generated question can be closed questions, such as true or false questions, and it can be an open-ended questions based on the previous categories. Also here's a sample of the generated questions. For comparison, for example, in the algorithm ontology, we can say that what is the difference between the tree representation and hash table, which is a valid question. In the concept completion, we can ask, explain the term algorithm, and here it is an open-ended question. Here's an example. Provide an example of NQ and compare it with DQ. Verification, also here it's a true-false question. In order is a type of tree operation, is it true or false? For feature specification, we list the characteristic, for example, of hash table, of hash search. Using this methodology, we generated 1,746 questions. The comparison questions were 1,068 questions. For the concept completion questions, we have 191 questions. For example questions, we have 358 questions. For the verification questions, we have 63, and for the feature specification, we got 66 questions. For the validation, our proposed approach will be the generated question will be evaluated by experts to decide whether the generated questions are valid or not, using the kappa calculation, which computes the inter-assessor agreement between those experts. For the question generation approach, we can use it for many applications, such as flashcards for in the classes, and for question banks, and can be used in self-assessment, and the ontology can be customized to be used in different domains to generate questions in many domains. So we can conclude that in our research, we addressed automatic question generation using semantic ontology, and we propose a systematic approach that contains ontology determination, analysis, term creation, question generation, and validation. And it holds potential for practical application to empower educators with tools to enhance assessment practice and support personalized learning. And here's the references, and thank you. If you have any questions.